All right, let's look at the homework 1.6, problem number 1. All right, let's look at this rational function. All right, so describe the intervals on which the function is continuous. All right, remember that when you have a rational function, it is continuous on its domain. All right, so we have to make sure that let's see, denominator is non-zero. Right, so you can see that if you set x squared minus 4 equal to 0, you see that x is going to be equal to -2 or +2. Right, so we cannot have -2 or +2. So what you do is all real numbers. So I'm going to go from negative infinity here, 2, right? Go all the way up to -2, right? Then skip -2. So we're gonna do union to combine intervals and the -2, and go to +2, and then skip +2, and then go all the way to positive infinity. All right, so we have that. All right. And let's go ahead and check the answer first. All right, looks like we got the first part correctly. All right, so second part, identify any discontinuities. All right, so you can see that obviously discontinuity is at the -2 and a +2. So I'm going to put -2 and a +2. All right, let's check the answer. All right, it came back and looks like we got the second part correctly. All right, so if the function has any discontinuities, which we do, we have 2 of them, identify the conditions of continuity that are not satisfied. All right, so there is a discontinuity at C being a +2 or -2, where f of c is not defined. All right, let's look at the picture. All right. So you can see that at the -2 function is undefined, and +2 function is undefined. All right, so there is a discontinuity because the function is not defined. All right, there's a discontinuity at x equals c where limit exists. Actually, limit does not exist there. You can see that you have an infinite limits, which means that those limits do not exist. All right, so here there's a discontinuity at x equals c where limit does not exist. Right, this is actually the reason. All right, there are no discontinuity. Actually, there is. So those are the 2 correct ones. All right, so let's check the answer. All right, it came back and looks like we got the third part correctly as well. All right, that's it. I hope that this was clear.